Hello everyone, welcome back to Technical Professor. So, in this video, we are going to learn about uh, machine learning algorithms, and we understand what are the basic maths required for machine learning, and we understand most important truth like machine learning is not magic; it is mathematics applied to data. So, in this lecture, I will completely remove the fear of maths. We will not do complex proofs. Instead, we understand each formula and means where it is used and why it exists. So let's start it. So let's see. Let me clear. If you understand, if you don't understand maths, you will use models blindly. Okay, and you won't know why accuracy is low, and you won't understand why training is slow, and you will struggle in interviews. So maths help you in understanding models, improve performance, debug errors, and think like an ML engineer. All right. Okay. So let's learn mathematics pillar of machine learning. So there are four pillars. First one is first one is linear algebra, and second one is second one probability, and third one is statistics. And fourth one is calculus. Linear algebra, where it is used, it is used to represent data. Okay. So where is probability used? Handle uncertainty. And statistics, understanding. It is used for understanding the data. And calculus for training. So every ML algorithm is combination of these four. Yeah. First one is linear algebra, and second probability, third statistics, and fourth calculus. Okay, so now what are scalars, vectors, and matrices? So what is scalar? A scalar is simple numerical values such as example salary equals to 50,000. This is written as salary equals to 50,000, and this is written as x belongs to real number. And what is vector? Vector is an ordered number array of number represented at x equals to x1, x2, like that in this way. So in machine learning, vectors are represented features of data points, allowing models to process and analyze information efficiently. Each component of vector is corresponding to a special feature, and together they enable complex mathematical operation. So in simple words, I will represent vector represented by SC22, 500, 600, and the components will be age, salary, and experience. Okay. The matrix also represented by in this way. So in embedded data set are matrices, rows are samples, and data set are matrices, and rows are samples, and columns. What are the columns? Columns are features. Okay. So what are vectors in machine learning? So, in machine learning, feature vectors are essential for representing data points. Each vector, such as x equals to x, x1, x2, x3, encapsulate keys attributes, enable algorithms to learn and make prediction effectively. So, suppose we are predicting house prices, and for example, x equals to size, bedrooms, score. Okay. Size is 1200, bedroom are 3, score it. So this model never see house. It only see this vector. Okay, these are the vectors in machine learning. Alright, now understanding the dot product. So now comes the core ML operation, that is the dot product. So x dot w equals to sigma xi wi. For example, x equals to 2 and 3, and w equals to 4 and 5. All right, so now we have to do the dot product. What we will do? 2 into 4 plus 3 into 5. Then x dot w equals to 8 plus 15 equals to 23. So this operation is used to calculate prediction in linear regression and logistic regression and neural networks. All right, so now we will understand matrices in machine learning. In machine learning, data sets are often represented as matrices, where each row corresponds to an instance and each column represents a feature, allowing effectively data and manipulation and data analysis. So now imagine we have 1,000 houses and three features. Like then matrix will become and the weights are stored as matrices will be. So ML is basically matrix math at scale. Okay. In this way, they are matrices are represented by row and columns. Okay. So now what is matrix multiplication? So predicting equation will be y equals to xw. This single means multiply feature by weights and combining result and generating predictions. So in this way, we will use linear transformation, data set representations. Okay. So this is a matrix multiplication. I can do one matrix multiplication like that. This is the example. So we have to multiply these matrices. In this way, we will then in this way we will do with this also. And in this way, we will do this with this. Then with this also. AB will be 1 into 5 plus 2 into 7. 5 plus 14, that will be 19. Then 1 into 6 plus 2 into 8, that is 16, plus 6, that is 22. And 3 into 5 plus 4 into 7, that is 15 plus 28. We have to add this, that is 43. Then with this, 6 into 3 plus 4 into 8, that is 50. So in this way, we will do matrix multiplication. So in this, there are linear transformation. So linear transformation is a fundamental concept in machine learning. It refers to the process of transforming input data into different spaces, like with different representation of machine learning. But in this, often we will use matrix multiplication. But in dataset representation, we will denote it by x, where each row is corresponding to an individual data point, each column corresponding to a feature. When multiplied by weighted matrix W, then result is a new matrix Y, which contains the transformed feature ready for the feature processing algorithms such as regression or classification. Okay. So now we are going to learn about probability basics. Okay. Let's learn. So probability is the measure of probability is the measure of how likely an event is to occur, with value ranging from 0 to 1. 0 is impossible and 1 is certain. And formula will be favorable by the, its measure uncertainty, whether this process will be happen or not. For example, if you study hard, you will pass. There is no surety. If you study hard, then you will pass. So, for example, we cause it on probability of head will be 1 by 2. That is zero point 0.5. In ML models, rarely says yes or no. They say there is 90% chance. Okay, so let's study to learn about conditional probability. So, unlike conditional probability, what is probability of A given B in this way? Like it is quantified the likelihood of an event occurring given that another event has already occurred. It is expressed mathematically. P of A by B equals to P of A intersection B divided by P of B. For example, probability of rain give clouds. So ML uses the data to update decision based on new data. All right. So Bayes theorem. So in Bayes theorem, it is a powerful method for updating probabilities on new evidence. That I have to use erasure, meaning old belief, that is new belief. It is used to update prediction when new data arrives. Usually useful in spam detection, medical diagnosis, and fraud detection. So classification also is crucial in machine learning. It's particularly used in logistic regression. It determines the likelihood of sample belong to specific class based on calculation probabilities. Okay. So now statistics. It is used to help summarization of data. For example, there are we have to calculate the mean for these marks. We will calculate it 60 plus 70 plus 80 divided by 3 equals to 70. This tells us the center of the data. Okay. So now variance, the form of variance will be, and standard deviation will be. So I will use this to normalize data, detect outliers, and improve model stability. So standard deviation also measures spread of data around the mean. A low value indicate that data point are close to mean, while a high value give certain greater probability. So what is the importance of data handling? So bad data, bad model. So statistics helps identify noisy features and handle outliers, compare model performances. So these are the function derivatives here, like y equals to f(x) and derivative represented by dy by x. You have learned this in 11th and 12th. And derivative, how fast output change when input changes. So let's see understanding derivative. So it imagine walking downhill. So it's direction to move, how speed the slope of is. Okay. In ML, derivative guide us toward minimum error. Loss function. So loss function will be if prediction of far from actual value, loss is high. Training helps to reduce the loss. And the gradient descent. So it's used to adjust weights and reduce error and repeat until learning stabilized. This is how machine learns. Optimization. So during training, global minimum best solution, local minimum good but not best. global best, and local good. So why model gets stuck, and why learning rate matters. That is the meaning of optimization. So summarization will be today lecture will be linear algebra, store data, probability handle uncertainty, statistics, patterns, and calculus learning. So in this lecture, I made the math clear, like the wouldn't comment linear algebra for the next lecture. So thank you so much for watching this video.